In this video we're going to use an algebraic method in order to find the conjugate points on a sphere. So we have a sphere here, and if we take the point A, then if we were to travel around in a great arc round this circle, then it would pass through this point A dash. Now we could choose an infinite number of great arcs round this circle that pass through point A. Now every single one of them would come round and have to pass through A dash. We see that A and A dash are points which are conjugate to one another. Now, in order to find the great arc, what we can do is we can take the intersection of a plane which passes through the origin and intersects with the surface of the sphere, and that intersection will provide us with the great arc that we're looking for. Now, that's called the geodesic on a sphere, and we've already derived an equation which gives us that plane whenever we did the video on the geodesics in a sphere, so you can have a look at that if you haven't seen that video. We did that previously. So the equation it gives us for that plane is cos phi plus beta equals tan alpha upon tan theta. Now what we have here is, if we were to draw that out, and let's say the blue point is a point in a sphere, if that's your z-axis, x-axis and y-axis, then the point in the sphere is given by the angle phi. Now the angle phi is the angle around here, and it sits in the xy plane. So you travel around here until you hit that point there by an angle of phi, and then you would travel up the way until you hit this point here, and we would have another angle there, theta. Okay, so the angle phi is going to give you the longitude, and the angle theta is going to give you the co-latitude. So it's not quite the latitude, it's actually 90 minus the latitude. Okay, so that's that angle theta. Now what we have to do is, if we have to show that if we pick a point on the plane, say the point A, which is theta naught phi naught, then in order for the conjugate to be diametrical opposite, then the A dash, the conjugate point of A, would have to be theta naught plus pi comma phi naught, and that's what we're going to show using the analytic method that we derived in the previous video. So if we take this equation here, again check out the geodesics of the sphere because that's derived in that video. So we take that equation there, and if we write it in terms of phi, so you end up with a phi equals inverse cos tan alpha upon tan theta all minus beta. Now also note that the values of alpha and beta are constants here. Then if we were to then say that we'll let theta be the independent variable and let phi be the dependent variable, okay, that's just a choice we make, then from the previous video we've seen that we can find the conjugate points by applying this equation here. So partial phi by partial alpha divided by partial phi by partial beta equals partial phi by partial alpha upon partial phi by partial beta whenever theta equals theta naught. Now what we want to do is differentiate this function here with respect to alpha. So in order to differentiate a inverse cos of a function, that's given by the function is inverse cos, and the derived of that function is 1 upon 1 minus x squared to the half. And also note it's a function of a function, so this part in here has to get differentiated as well. So when we theta just acts as a constant because we're differentiating with respect to alpha, and the tan alpha, if you differentiate tan, you get the sec squared. Okay, so it means that we're going to take this out, that'll become sec squared alpha and upon tan theta, so that's going to give you the first section here, and also this part here is just going to be the 1 upon 1 minus tan squared alpha upon tan squared theta all to the power of a half. Now whenever we differentiate partial phi by partial beta, well it's just going to be partial phi by partial beta, you're just going to have the beta term there because it'll just going to be partial beta upon partial beta, which will be just 1. And now it's the same on the other side as well. The only difference is we're replacing theta with theta naught. Okay, so you end up with this equation here. Now what we can do is we can cancel out the sec squareds, and then we can find the reciprocal of both sides, and we can also square both sides, which will get rid of the power of a half here. So we end up with our tan squared theta 1 minus tan squared alpha upon tan squared theta equals tan squared theta naught 1 minus tan squared alpha upon tan squared theta naught. Now from here we can multiply out the bracket, so we get our tan squared theta, this cancels with that, and we get our tan squared alpha. Again, tan squared theta naught multiplies with the 1, and the tan squared theta naught cancels with that one, and leaves our tan squared alpha. And these two tan squared alphas can cancel, and you end up with the tan squared theta equals tan squared theta naught. We take the root of it, so you end up with tan theta equals tan theta naught. So the tangent can be drawn out like this here, okay. And the thing about the tangent is it repeats every 180 degrees, okay. So in order for tan theta equal tan theta naught, then the value of theta must equal theta naught plus m, an integer number, times pi, okay. So that really shows then that both points are actually diametrically opposite on the sphere. So if we have the point A equals theta naught phi naught, then the point A dash must be equal theta naught plus m pi comma phi naught, okay. So then what we've done then is we've shown that the conjugate points on a sphere are diametrically opposite, and we've used the equation which we derived in the previous video in order to prove that. So I hope you enjoyed this video. If you found it useful, then don't forget to subscribe or leave a comment. Thank you and goodbye.